Hello everyone, this is Robert. In the last video, I talked about doing something crazy with the Prusa XL, and that's what I'm going to attempt to do in this video. I want to come up with a test part, because I don't really have anything in mind right now for a project, but I want to come up with a test part that kind of shows off the capabilities of the tool changer on the XL. So what I want to do is I want to combine PETG, PLA as support for PETG, something abrasive like carbon fiber PETG, and then two different flexible filaments all together in the same model with no wipe tower. That's the goal, so let's see if we can do that. Let's take a look at the design I came up with. So this is the multi-material coaster. It is just a drink coaster that I kind of designed a lot like a Benchy to test out as many of the aspects of multi-material 3D printing with a tool head as I could think about. So let's take a closer look at this. First up, we've got this grid up top. This is all a red TPU. This is a softer TPU. I think it's a poly maker that I'm using for this. And this is actually inset inside, so we're actually doing some overlapping down in here. Not overlapping, but it's, set inside, so we get to see how clean that transition is, and it's also set into this side wall as well, and I'll show that better in the slicer. So that is a TPU. The outer ring is going to be a PETG carbon fiber, so we're doing an abrasive on the outside, mostly doing that just kind of for the texture. And also, carbon fiber PETG tends to be really bad at overhang, so we've got an overhang that we're going to be supporting with PLA. This center section right here, this piece is all going to be PETG, and that's kind of the internal structure of this part. Then on the underneath side, we have another set of TPU rings. Another set of TPU rings here on the inside. And the idea is, well, obviously this is, the coaster on the bottom, but I want to kind of test stringing. So with these concentric rings, we can test the stringing in one way, and then on the top, we can kind of test it with this more thin-walled feature, and two different TPUs should give us a lot of test results. And then on the bottom, what I'm trying to test here with these grooves is I'm trying to see how not only PLA will support this outer wall, but how it will support the bed of the PETG that will be down here. So one TPU, two TPU, one PETG, another PETG, and then PLA for support. So that is all 5 tool heads, and we should be testing a lot of different things here. For saving this and bringing this into the slicer, all we have to do is file save as, and we're going to save this as a 3MF. So as long as we save this as a 3MF, it will be brought in basically as an assembly. All the individual components will be brought in because these are all made individually as their own components. So yeah, pretty much all there is to it. So before we get talking about the slicer and get this printing, I think it's really worth talking about setting all this up. This is very different than putting a spool of filament into a printer and hitting go. It takes actually a fair amount of time to get all this set up. As you see, I have all these filament dryers going. I didn't start out with the filament dryers, but then, it was taking a couple days to play around with, so then the filament got moist, and then I had to throw on the filament dryers, and you have to eject the filament out, reload it. Loading TPU is a bit of a pain on this printer. It does work, but it's a little bit fiddly, and you kind of have to, do some weird things. But overall, this takes a long time to kind of just get a new job set up, especially if you're using all 5 tool heads, because, it takes a few minutes for the tool head to get up to temperature, eject out the old filament, feed the new one in, purge it, all of that good stuff. Additionally, since I have the 3 filament dryers running, I have one on the carbon fiber and then one on each one of the TPUs. Those are kind of the most critical. You have 4 plugs right now. The printer plugs into one, and then each one of these needs its own plug. And of course they have, the big wall wart thing. Those don't always fit cleanly into a power strip. So I've got a couple power strips here on the floor just to run these. If I had another 2 filament dryers, I probably couldn't even use this area of the workbench. It would just take up way too much room. And yes, it is very, very windy outside. The other thing to think about is I have a hard nozzle. For tool head 5, I end up putting a Diamondback nozzle in with the V6 adapter. And anytime you swap out a nozzle, especially for this kind of application, you're going to want to run through that nozzle calibration. I talked about that in the last video, and I did that in the last video. It takes about 15 minutes to run through that whole calibration, which isn't too bad. But if you're going to be swapping out nozzles, like, okay, I'm going to do 0.6 millimeter for this and swap everything, you're going to add another 15 minutes. You're going to have to eject out all the filament, clean out the nozzles, swap them in, and then run through the calibration. The last and final thing I wanted to talk about with the calibration is cleaning the nozzles. It prompts you to clean the nozzles, but I decided not to, just to see what would happen. And it's actually pretty cool. It will detect that the nozzle is not round because it goes and probes all around that little pin, and there is some stuff on the end of one nozzle, and it said, hey, this isn't round, we're gonna throw out these values. Good news, it caught it. Bad news, you basically have to clean it and run through the whole thing again. You can't do individual nozzles, which is kind of annoying. But something to keep in mind is if you are going to be swapping stuff around a lot, you're going to have to run through that whole offset calibration every single time. So I've got a confession to make. This is not the first one. This is, of course, the 4th one that I've printed. And I've gone through a lot of iterations trying to figure out the process and, kind of learn how all this works. And I'll say this. It wasn't what I thought it was going to be. I thought that getting these to all print was going to be difficult. That was actually really easy. The very first one that I did printed pretty much perfectly fine. There's just a couple issues with the wipe tower that I'll talk about in a second, but it was really designing the part and coming up with the idea for, okay, how do I incorporate all of these materials together? That was actually the more challenging part. Getting the printer set up, getting, the filament dryers, getting all the filament loaded and into the proper heads, and then putting on the diamond nozzle. Getting all that set up was kind of a pain. And then the slicer is actually pretty straightforward. The biggest issue that I ran into was the PLA and PETG. Using PLA as a support has turned out to be kind of complicated. PLA and PETG don't stick together, and that's why PLA works as a good support material. However, the problem is that if you're using them together, it kind of means that you can't use a wipe tower. In the slicer, if you enable the wipe tower, whatever extruders are being used, it will just purge them into the wipe tower. Well, the problem is if you have a layer of PETG and then you switch tools, grab the PLA, and then go to lay that down into the tower, it just won't stick. It'll just kind of glide right over top, and then it'll just string everywhere and you'll have problems. It's like printing in the air. So the biggest thing that Prusa needs to add to the slicer to make all of this super, super simple is the ability to have multiple wipe towers and the ability to assign extruders to the different wipe towers, or the ability to assign them to no wipe tower. For instance, it would be really nice if you could say, okay, enable wipe tower, and I want 2 of them, or 3 of them, or 1 of them. And then you can say extruder 1, don't wipe. Extruder 2 goes to the first wipe tower. Extruder 3 goes to the second wipe tower, and so on and so forth. Because you're using dissimilar materials that don't really play well together, kind of by definition, that's what we're trying to do here, you can't really use a single wipe tower. It will create issues. I don't necessarily want like a TPU and carbon fiber in the same wipe tower. That might have an issue. So the ability to select multiple wipe towers and the ability to have extruders be wiped or not be wiped, that is the critical feature that I was missing here. So here are the first 4 that I made. I made 2 without the grid pattern. So first, second, third, and then this is the one that just came off the printer. If we look at this first one, it looks pretty good. You've got a little bit of a seam up there. Everything else looks pretty decent. And on the back side, the TPU looks pretty good. Could have done a better job at supporting the PETG. I'll get to that in a second. But the biggest issue is this seam right here. You can hear I'm printing out the 5th one right now. This seam right here. This is why you need the purge tower. The PETG comes in and it has this nasty bump right there, gets bad, and then it just kind of gets better and better and better until right there, then it prints out just fine. So I think unfortunately for a lot of models and a lot of applications, you're gonna need to turn on some sort of purge tower. For this model, there just really isn't a big enough solid body to purge into that and then start doing the perimeters. You just kind of don't have that option. So what I changed between this one and this one, I really didn't like how the PLA was supporting the PETG down here. I changed some of the settings. I got the support just a lot closer to the PETG, so I kind of changed that. And you can see on this one, much better. The surface finish of the PETG is better. Not perfect, but quite a bit better. In this, I had this outer seam aligned, and I thought what it would look like is random. Changed it to random, and that's really bad. You have just a lot of zits and nasty stuff all along the edge. I don't know, is that in focus? Yeah, so it's just kind of little blobs all along that outer edge. So that did not help. For these final two, I was just adding in the little honeycomb pattern on the top. And at first glance, it looks pretty good, but on the camera you might be able to see there's just little wisps and bits inside the honeycomb. I specifically chose the red, the gray, and the black for the contrast. And you can see, you know, there's a little bit of cosmetic issue inside there. The TPU is definitely stringing into the PETG. And on the one that's printing right now, I have the temperature lowered to kind of correct that stringing. We'll see if that helps. I'm also actively drying it. We'll see if all that happens. Also, you might see an extra lip on the outside. That's just a feature I added to try and mess with the model. And this one, the edge is really nasty. This was random seam, and I tried some different settings for the PLA support, and that did not work. This is really rough. It feels horrible, and this one just really didn't work out. So need to try some different settings there. And then this is the final one, and I think the grid looks maybe a little bit better. There's still some issues inside of there. I didn't really change too much, but changed some of the settings on the PETG carbon fiber, so that looks a little bit nicer. And on the underneath side, this is probably one of the worst ones. I got way too close. For the PLA and PETG, I set the interface distance to basically nothing so that they're fully touching. And what happened is, even though the PETG and PLA don't actually melt together, the blobs on one kind of formed into the blobs on the other, and it just kind of formed, I don't know, this bond between them, and it's really ugly, really nasty, and these supports didn't come off cleanly. And then on here, I had it set to a circular pattern instead of rectilinear, and you can see that it really just didn't support the PETG. So this was a lot of bad settings. So we're printing a fifth and final one, and we'll see how that works out. So while this final part finishes up, let's talk about some of the challenges that I've seen up until now. This model was, I think, a good test because I ran into a few things I didn't think I'd run into. The biggest one is using PLA and PETG together. Since they're kind of oil and water, they don't bond together, we can't use a prime tower. And that's kind of what I wanted to test in this, but halfway through this test, I'm like, I'll just turn on the prime tower and we'll see what it looks like, but I can't because the PETG and the PLA won't work together in the prime tower. It won't stick, it'll fail, it'll create strings, it'll be an issue. I've tried. So what it comes down to is we need the ability to set two different prime towers and assign the extruders to the different prime towers, or just choose not to prime into that. When this is printing the PETG, it starts by pushing out a lot of material and then starting, and you have that issue with the little blobs on the side. I think part of it with the PETG carbon fiber is it's at a much higher temperature than the rest of them, so it has a lot of back pressure built up in the extruder. That could just be a guess, but it's the only one that's really having that issue. The TPU isn't, the PETG isn't, and the PLA isn't. It's only the PETG carbon fiber, so something to keep in mind. However, for a small model like this, a prime tower wouldn't be a bad thing. If you could, say, purge everything except for the PLA into the prime tower, then I think this model would be perfectly fine. You'd have a very, very, very small amount of filament in that purge tower. no problem whatsoever. For a larger model, you would have a larger solid body that you could then just select purge to infill on that body, and then you'd have not an issue. So I think the biggest issue that I'm seeing right here is using the PLA and PETG. Any two materials that aren't going to bond together prohibits you from creating a good or usable prime tower, but then because it's small, you don't have a large solid body big enough to purge into the infill. So that's kind of where we're at. But mechanically, everything's printing great. The TPU is printing really nicely, the PETG is printing nicely, the carbon fibers, everything individually is printing nicely. It's just that initial purge that's the only issue I'm seeing. Okay, so let's talk about the slicer. There's really not that much to talk about. It's all pretty straightforward. So if we import our model, you can see that I just selected each one of these individual bodies and then just assigned it an extruder. And then up here, I have my 5 different filaments. Now you might see that there's no number 1 over here. To set the support material, we do that over here in multiple extruders, not the support. You can see that you can set the extruders here, and you can have a different one for different things. You can have like the interface be one thing, the infill, the perimeter, but I just have all of these set to 1 so that when we slice this, you can see that it selects PLA for all of the support. See, all that white is the PLA, and that's what's supporting all of the lower filaments. Another thing to note, if we go into support material, here's the things I changed. Obviously, generate support material, top Z contact distance, we have that set to soluble because the two don't actually melt together, so we can have that set to 0 millimeters. Rectilinear versus concentric. I'll mention that in a second, that's a pain. Then the interface spacing we have set to 0, and then on build plate and 50% separation. This 50% separation is how much separation there is between the actual support and the model on the X and Y direction. I have it set to 50%. If you have it too close, then these supports just kind of wedge in there. If it's too small, then you're not fully supporting it the way you want. Now, rectilinear versus concentric. Right now I have it set to rectilinear. Let's see what that looks like. Go down. So let's look at this inner layer. This kind of dark gray or medium gray is the PETG, and that is what the top of the PLA looks like. That's nice. That will very nicely support the PETG. However, if we look at the outside, look at that little squiggle. That is what's supporting the outer surface. That is not ideal. So if we go over and switch this to concentric, it will be good for one and not good on the other one. So unfortunately, you can't select different settings for the different parts of the model. That's why I'm saying you would just model up the infill and add that in like all the other pieces. So you can see now over here, this is going to support the outer walls well, but on the inside, these concentric rings didn't really work out well. It was they really don't stick together, and it actually interferes with the TPU. So this was problematic for that, but better for the outside wall. So you kind of got to pick and choose the lesser of all evils. I think that's really all there is to talk about. You don't have a lot of options for the multiple extruders. I have the wipe tower turned off. And in terms of setting the filament temperatures, this was actually a little bit of a pain. You can really only modify one at a time. If I go and click on PETG carbon fiber and go to modify it, it will ask me if I want to bring over the changes from the flex that I made or discard them. And if I discard them, they're gone. If I carry them over, now carbon fiber is the same as the TPU. So that's kind of a little bit of annoyance. You basically have to just make and save your own new profiles every time. But yeah, that's pretty much all there is to the slicing. Pretty simple. So here is the last and final print. It looks pretty good. There's still a little bit of the TPU that found its way into the PETG. If we cover up that side, that's actually really good that there's just a couple, like those 3 cells right there. So let's get the supports off of this. So this is probably the best overall. I think it did a pretty good job of supporting the outside edge. I changed it back to aligned, and you can see it's still pretty ugly. A prime tower would absolutely help that. This just kind of needs to be primed, and we're getting some issues around there. I'm not really sure what happened there. If we ignore that, that is a really nice finish on the underneath side. It did a really good job supporting the PETG. Not really sure what was happening there. I've been having some issues with this gray PETG, so I'm not sure if it's just the filament, but everything else looks pretty decent. There's a little wisp right there, but honestly, the TPU on the bottom is pretty clean overall, but not perfect. It definitely needs some more work and needs some tweaks. This is about as far as I'm going to go with this for right now, but I think I learned a lot from this. I think I learned that functionally it can do this. Cosmetically, there's definitely some tweaks in the slicer that need to be made for this to be perfect. That bums me out. But other than that, I think I have a pretty good idea of how to use this machine and what its capabilities are. So, as always, thanks for watching. Please leave a comment if you have any questions, want me to try some different things. I think my next big investigation on this machine is going to be with a real project. Doing these test prints is nice, but now I'm done with it and, well, I just have a coaster, I guess. So anyway, as always, thanks for watching. See you in the next video. Bye. Oh yeah, almost forgot. Thanks for watching.